We are continuing to work on number sense by comparing decimals. Let's compare 12 hundredths to 3 tenths. First, let's talk about place value. This place is the tenths place. All right, so the tenths place, we would write this as 1/10. This place is the hundredths place. Sorry that it's taking me a while to write this. All right, hundredths place. Now, a lot of times students will think, well, this is the larger fraction because it says 100, and this is the smaller fraction because this says 10. But that is not the case. It's actually the opposite. And the reason is this. If you take a whole pie, one whole pie, and you divide it into 10 pieces, your slice might look something like, I don't know, this. But if you take a pie and you divide it into 100 pieces, your slice is going to be very tiny. Probably tinier than that, but it's hard for me to draw a slice tinier than that. Because basically you're taking 1 and dividing it into 100 pieces. So 1/100th is going to be a very tiny piece, and 1/10th is going to be a larger piece than 1/100th. So these are the larger pieces. So this number 1 represents 1/10th. And this 2 represents 2 of these tiny hundredths. So we would start by comparing this number to this number. We compare the tenths. This has 3 tenths, this has 1/10, so this number is larger. So we would read this, 0.12 is less than 0.3, or if you read it backwards, you would say 0.3 is greater than 0.12. And I think an even easier way to compare them is to just make sure they have the same number of places in their decimal. So we could just add to this 3, we could put a 0 beside it, and then compare 30 to 12. Well, which is larger, 30 or 12? Well, 30 is larger. All right, so on the number line, it would look like this. We'd have 0 here. We could go up by tenths, that could be 0.1. This could be 0.2, this could be 0.3 or 3 tenths. So 3 tenths is right here on the number line. And then 0.12 would be about here. And remember that the further you go to the left, the smaller the number is. So this number is further to the left, so it's smaller than the 3 tenths. All right, let's keep going. All right, so I'm going to use the easier comparison where I just add a 0 so that they both have 3 decimal places. And 370 is larger than 365. Now it gets a little bit confusing because now we're looking at negative numbers. So I'm saying that in terms of absolute value, 0.370, 370 is larger than this 365. But the tricky thing here is that this is a greater amount, so it's a greater negative. So it's going to take me further to the left, this 0.370, than 0.365. So if this moves over 370, this one only moves over, 365. 0.365. So this one is more negative. You have more negatives here. So it's going to take you further to the left from 0. And remember, as you move to the left, the numbers grow smaller. So this number is smaller. And as you move to the right, the numbers grow larger. So this number is larger than the negative 0.370. So negative 0.370, it's further to the left, so it is less than negative 0.3650. Or you could read this backwards and say negative 0.3650 is greater than negative 0.370. All right, when comparing these, a lot of students think that these are different numbers, but really, sorry, let me get the color, the proper color. But really, this 0 in front, a lot of times they like to put that 0 in front on EOGs and testing to make it look more clear, but really 0.2 is the same thing as 0.2. I could add a 0 just the same to this 0.2. These are equivalent, they're the same thing. The same goes for this problem. Whoops. Some kids don't realize that these two are the same number. So they look at this and they see a 5, and they look at this and they see a 50, but really 0.5 is the same as 0.50. You're allowed to add a 0 onto the end of this. I mean, honestly, I'm allowed to add as many zeros to the end of this as I want. But really, remember, we're comparing this first spot. They both have 5/10. Or, I guess I should say negative 5/10. So these are equivalent numbers. All right, and then this last one, 0.401, I'm going to add a 0 on the end of this. And 4010 is greater than 4009. Or if you read it backwards, we would say 0.4009 is less than 0.4010.